There we go. All right, so I'm going to start this. Now, remember, everything that I cover is going to be on that last test, which is December 3rd through December what? 10th. Good job. What?
I was making it. I said, what week? I just wanted
Pink horns. All right. I want to order one of those for my daughter. You need to tell me where you got that. Anything to kill people, yeah. That's what I want to give my daughter, yeah. All right, slideshow. Okay, now we're estimating a population proportion, underline proportion. Okay, go ahead and write. You don't have to write down every single word. Just write down a little ad lib for each one. But I want you to highlight the word proportion because we are figuring a proportion, which means a percentage. Write down percentage under that because that's where you're going to use X over N. Remember? P hat? Is that one of those words that y'all just like to hear? P hat? Y'all just laugh when you hear it.
Pizza. French onion pizza too.
This is when you need to be quiet. Because you already got your foot in the grave. You need to quit digging it deeper. After the French fries and French bread comment, we don't need to talk no more.
And he said, have you ever been to Olive Garden?
Have you ever been to what?
Olive Garden. How did you miss that?
Like I said, if my son was in here, you couldn't tell the difference. He'll do the same thing. We'll be going down the road, we'll be talking about the farm, or we'll be talking about the truck, we'll be talking about something at the house, and he'll come from left field, just out of the blue, just. Now, in chapter 9, we're going to be working with the null hypothesis and the alternative hypothesis. Now, remember, the null hypothesis is real simple. The null hypothesis is always going to be equal to. Okay, equal. Remember that? You can write it down now, you can write it down later. It's always equal to. Now, what's opposite of equal to? Not equal to. So everything else is going to be the what? Alternative hypothesis. So when you're looking at a sentence or a paragraph, and they say the population is equal to 0.6, or the proportion is equal to 0.6, then you have P hat, okay? And they're telling you that that is the, or whatever they're asking you, if you see the equal sign, or you see the word equals, that is the null hypothesis. And whatever the complement of that is the what? The alternative. Now, that's one of the biggest problems students have in Chapter 9, especially in high school. They don't go into that enough. And it's real simple thinking. Just like I told you before, what is the alternative hypothesis of guilty? It's not innocent. It's not guilty. Because innocent, you shouldn't even be in the daggum, what do you call it? Courtroom. Dang old cameras and stuff. Eyewitnesses. Alibi. All right. Same thing with the roulette table. If you want to find out the probability of even, the alternative to the probability of even is the probability of what? Not odd, because of the zero and the double zero. Not even. And we're going to get into that. And there again, the point estimate. Write this down. This is very important because it's just a proportion, but it changes with each because we're going to be given, sometimes you're given the proportion, sometimes you're given the mean, sometimes you're given the standard deviation, and you have to back it in that way. So the point estimate is the value that estimates the value of a parameter. What does parameter go with? Remember the first unit? Parameter goes with what? Greek letter goes with the what? Population. Good. You were the one that listened. Okay. Population parameter, sample statistic. So if you're given a point estimate, then we're talking about the population because it is a parameter. And that's why it says population proportion. So what's the opposite of p hat? Q hat. And you don't really need to, the only thing you need to write down is the point estimate, is the value of a statistic that estimates the value of a parameter, and in parentheses behind parameter, put parentheses population. All right, here's an example. Calculating the point estimate. Now, when you're calculating the point estimate, you're pretty much calculating p hat. Sometimes they're going to give it to you. They say p hat is 83%, or they won't say p hat. They'll say the proportion is 83%. You don't sit there and go, oh, what's the proportion? 83%. Percent, proportion, probability. So, in a Quinnipiac, and that is that along with Rasmussen, that's your biggest polling companies, our university, asked 1,783 registered voters nationwide if they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Okay? Then what does that mean? What is p hat? I'm sorry. Say again, I couldn't hear you. All I was mumbling.
Are you saying like the number of people in favor over the number of people who registered?
X over what? N. X over N. So write down p hat, and then I want you to write down q hat. Every time we do p hat, I want you to write down q hat. That way you won't be mesmerized when you see it on the test, whether it be my test or whether it be a standardized test. So p hat is going to be 1123 over 1783. I don't believe in the death penalty. I believe everybody should be, if you're convicted of a crime, then you should be dealt that crime. Simple as that. Make it simple. So what's q hat? Now q hat could be 2 or 3 different. You could make a proportion. So what's 1123 from 1783? Dang old 650? I have no idea. What is it?
660.
Okay, so that would be 660 over 1783 would be q hat. Or what's the decimal representation of q hat? 0.37?
0.37.
So make sure you write that down because I want you to remember that. Confidence interval and confidence level. This is very, very, very important. On a scale from 1 to 10, this is about a 15. So you need to write these two definitions down because this is all about the rest of what we're going to be learning is based on these two guys right here. Remember when I told you that you don't walk into a board meeting saying, oh, I'm about at 75% confidence level. No. 90% or above. You don't expect 100 because nobody's what? Nobody's perfect. So 90 to 99 is what you want to go for. I tell students 95 to 99. If I was making a lot of money with Michelin and I was an executive for quality assurance, I'm not walking into a board meeting without a 95 or better confidence interval. Unless I just want to half-ass do it and lose my job and then cry and whine about it when I get fired. Something about raising the bar is awful, isn't it? Doing the best you can. The confidence interval is going to be written kind of like in your interval notation. P is between, got a greater than, less than or equal to sign. From 75 to 100%. So that would be, P is going to fall between 75 and 100%. Confidence level is that level. Now write that down, 1 minus alpha. Okay, we're going to go over that. We're going to figure some, and I'm going to tell you to take an index card and actually make an index card of this. And the only reason I do that index card is so, time-wise. If you didn't have these two definitions, you wouldn't have a chapter 9 or a chapter 10. Okay? No? Gotta get my vodka in. My daughter works at the galley, and she's starting to learn the whole thing about fake money and real money. Real money comes in, treats you decently. Fake money treats you like a slave. Anyway, she's starting to figure that out. So I don't know what time they open, but they open pretty early. You know, I think 4 or 5 o'clock. I think they open. I can't remember when they open. But anyway, she said a woman came in. She said she must have had a hard week. The woman ordered vodka on the rocks straight and drank like 3 of them. And I'm like, oh my gosh, that's like drinking Everclear straight. I mean, it's worse. It's like drinking paint thinner straight. And anyway, I'm saying, when you see somebody come in and drink 3 vodka straight, okay, one of 2 things are happening. 1, they're an alcoholic, or 2, they've had a real crappy week. One of those 2 things have happened. She said, I'll note that. I said, be sure you do, because if they're not alcoholic, then you need to worry about it because of your tip. So you need to treat them very good because they've had a crappy week. It's all psychology. Take all the psychology classes you can take. All of them. Unless you want to be in a closet and not interact with people, which some of you may need to do, but I don't know. Take all the psychology classes you can take. Everybody got it? All this will come together when we start doing examples, okay? Now, they're building up to it right here. They're building up to it. This is like a 1, okay? We're going to be doing like 5 or 6s, okay? These are 1s. These are real simple. For an example, a 95% level of confidence. 95% means that alpha is equal to 0.05. Write that down. Because you always take the complement of the interval or the level. Take the complement. That's what alpha is. Alpha is the complement of the confidence level. Write that down. We're also going to divide it by 2 and look it up in the table. Okay, so implies that 100 different confidence intervals are constructed, each based on interval, blah, blah, blah. We expect 95% interval, blah, 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 5 to include the parameter. I'm not really worried about that other stuff. The first sentence is what I'm talking about. For example, a 95% confidence level is going to give you alpha is equal to 0.05. Now we're going to divide that by 2. What is 5 cents divided by 2? 2.5 cents, which is 0.025. Okay? I hate to remind people, if you ask me a question after class and I start using my phone, what is that? So what is it when you use your phone and I'm talking? Okay? Just want to remind you, 2 people in here consistently do that. Okay? So I want 2 people to stop, please. All right. So, good? All right. Write this down. Your confidence interval is going to be equal to p hat plus or minus your what? Margin of error. That is something you need to really highlight. It's called the mode. Margin of error, mode. Okay? Here lately, why is margin of error? There have been a lot of polls. Why? What did we just have a few weeks ago? The election. There was a lot of polls. And down at the bottom, N is equal to blah, MOE is equal to blah. The lower the margin of error, the better. Write that down and highlight it. The lower the margin of error, the better. Now think about that. Why is the margin of error, if that was low, why is that better? That means your confidence is very what? High. If you say, well, I got a margin of error that's real high, that means my research sucks. you want a 2 or 3 or less margin of error. Anything above 2 or 3 is really questionable. Now, they're going to throw you 75% confidence interval. They're going to throw you 5% margin of error. Remember, homework problems are what? For practice. Homework problems are not for, what you really want in the real world. They're just for practice. What you really want in the real world is 95 to 99% confidence level, 3 or less on the margin of error. So if you're working, or let's say you're sitting in a meeting whenever you're working, and somebody throws up a confidence interval of 90%, and they say, okay, we had a margin of error of 15%. You're going to be saying in your mind, this ain't worth a flip, okay? This presentation is really trash. With a margin of error of 15%, that's not good. Capiche? So write down point estimate, p hat, plus or minus mo. That's what you're going to be figuring. You're going to be figuring a confidence interval, and you're going to be figuring at a certain confidence level. Okay, these are the two things: the level of confidence, sample size. They're going to give you a formula for everything. We're going to go through the formula, and it's going to be very simple. But when we get to the null hypothesis and the alternative hypothesis, that's where we're going to have to take it even slower, because that's where a lot of you. How many of you have had null and alternative hypothesis before? Was it real simple? Okay, you had a good teacher then. How many of you had it and didn't know what was going on? Anybody?
I was in biology, so it's easier.
Okay, because that makes sense. But some of you may have had this in probability and statistics. Anybody? Okay, how was your?
It wasn't bad.
It wasn't bad?
I don't remember it well, but.
You what? I didn't hear the second part.
I don't remember it.
You don't remember it? Okay. Anybody else? Well, I've heard horror stories. I've heard people didn't even know what was going on. So, I don't know. So, sample size, that's important. We got to figure out the sample size. What is the sample size? Well, let's say that let's say you got a job and you're told the Michelin, okay? The law of large numbers tells you the more you do, the what? Like in real life, the more you do, the what? The better. Okay? The more data you use, the better. Okay? So if I am the executive of quality assurance at Michelin and I want to project a number for next year for the budget, I'm not going to use a sample size of 5 tires. I'm going to use 5,000 or 500,000 tires. Okay? Because I want to make sure that I get my numbers right, because whose neck is on the line? Mine. And like I said, it's just called doing your job, or raising the bar, doing the best you can. I know for some people that's not good, but I hate it. For a simple random sample, N is the sampling distribution, P hat, blah blah blah, and the standard deviation right there. Remember, we've had this. The square root of PQ over what? N. Provided that MPQ is greater than or equal to 10%. Now, if you didn't write this down before, write it down now, just that last part. The standard deviation is equal to the square root of MP over N. I'm sorry, PQ over N. We got into this a little bit in chapter 6 or 7, I remember. Okay, when we did the square root of MPQ, and then we did MP, and then the square root of MPQ. Well, this bleeds off of that. Okay, so the standard deviation, population standard deviation, is equal to the square root of PQ over N. You could say P hat, Q hat over N. Provided that MPQ is greater than 10. So if you get MPQ is 6, that's not going to do any good. So you go to the next problem, you say, cannot do this problem. Okay? So just write down those two things right there. Now, here is your formula for your lower bound and your upper bound, or you can just put plus or minus. P hat plus or minus z times the square root of p hat q hat over n. You don't have to write down both. You just write a p plus or minus. It's just like your what? Standard deviation. What do you do on the right side of your standard deviation? Add or subtract? Add. What do you do on the left side of the...
Subtract.
Okay, so same concept. Your p hat is in the middle, just like your mean was. And when you added your standard deviation to your mean and you subtracted from your mean, that's how you did that. Now you're going to put p hat in the middle, and you're going to add and subtract accordingly. And that's going to be your margin of error. And that's probably what they should call it, confidence interval. That's what it's basically going to be. Okay, lower bound, p minus, upper bound, p plus. So you would write that as p hat plus or minus z times p hat q hat over n, square root. Again, we're going to go over this whenever we ever do get to the examples. They kind of drawing this out a little bit too much. And there is your margin of error, and then they're going to give us the formula for the sample size. So the margin of error is equal to z sub alpha over 2. Remember me telling you we're going to divide it by 2? There it is. All right, so put z sub alpha over 2. And we're going to do an index card, and we're going to actually do those. Okay? So you don't have to look them up every single time. I did watch a good movie on Fire Stick this weekend. It was Hunter Killer, about the submarine. That was a very good movie. I mean, it was very good. So if you want to see a good movie, that's a good movie. Anybody heard of it? It was on the theaters. It was called Hunter Killer. I think it's called Hunter Killer or Killer Hunter, one of the two. It's about this American submarine that goes and go in and save the Russian president. Anybody seen it? It's a very good movie. Very good. Huh? It's very good. It's along the lines of kind of like Hunt for Red October, kind of like that same. Very good. Both of them are very good movie. Have you ever seen Hunt for Red October? Very good movie. Anyway.
Is a Fire Stick worth it? Like,
Oh yeah. Gosh, yeah. Sometimes you get to see the movies the day it opens.
Really?
Yeah, if you're lucky. There used to be something called LimeWire. Y'all remember LimeWire? I don't know. Some of y'all may not because it's before your time. But it's where you could get on the internet and you could download all the music and movies you wanted to on MP3 player or whatever. Well, it was illegal. Some of the Fire Stick things are legal. Basically, you go to Exodus and somebody has went into the theater in China or wherever and recorded it, and that's what you see basically. But it's, every once in a while you get one that's legitimate. It's not recorded and it's real good. But you know, when you get it, and like I say, it's not free because you have to deal with somebody holding the camera and somebody walking across, so it's not exactly what you get, but it tells you if you need to go to the movie theater and pay the money to see it, if it's actually good enough. But that movie, Hunter Killer, is a very good movie. All right, so y'all got this? So you're going to have to look up the z-score, not for alpha, but for alpha over 2. So if your alpha is 0.05, you got to look up the z-score for 0.025. Everybody with me? And that's you got to remember that. Okay, here's the problem that we were doing a while ago. We took the 1123 over 1783, and I told you that p hat is equal, was it 0.63? So that little q hat is equal to 37. And they want a 90% confidence level. So write down 90%, and then say 1 minus 90 is equal to 0.10. Find alpha, and then take alpha and divide by 2. So what's 10 cent divided by 2? 5 cent, 0.05. So alpha over 2 is 0.05. Now, somebody tell me what 0.05 z-scored is. That's what you do, negative infinity to 0.05. Do that in your calculator. What is it? Normal CDF or PDF? You know, finding the area under the curve, which one is it? Normal CDF or normal PDF? CDF, y'all make sure y'all know which one it is. Go back to chapter 7 and look in your notes. And you're going to have to look up 0.05 z-score. Let's see if they take 90 away from 1. Well, they already did the 0.63. There's the 0.10, 0.05. Somebody look up 0.05 to infinity, or negative infinity to 0.05, and I'm going to show you. It's going to have negative 1.645. Right? I'm sorry, put 0.5. I'm sorry, inverse norm. Do inverse norm. Somebody do inverse norm 0.0500 and tell me what you get. Okay, negative 1.64. You ignore the negative. Okay, write that down. Ignore the negative. Because all we want, daggum wind blowing. All we want is what? All we want is a z-score. So that's 1.645. Okay, now, if you don't understand what I did, then you need to copy down this right here, because that's what I just did. This right here. You take 1 minus 0.9, and that's alpha. So $1 minus 90 cents is equal to what? 10 cents, 0.10. That's alpha. Alpha is your change back, okay? You take alpha and divide it by 2. What's a dime divided by 2? A nickel. And then that nickel is the area under the curve that you got to look it up. So you put in second bars, what is it, inverse norm? What number is inverse norm? Somebody tell me. 3. Look up number 3 and then type in 0.0500. Why did I type in 4 digits? Because it's a what? It's an area. And you're trying to find the z-score, which is 2 digits. So that comes up with 1.645. They use 3 digits, but it's whatever, 1.65, 1.645. And then that is your z-score. So my interval, yes ma'am. That's where they check it to make sure that it is above 10. Remember the test I told you? It's got to be above 10. If I said it was 6 and you couldn't do the problem, that's what they're doing. They're checking it. Most of the time, 90% of the time, the problem is going to be doable. I don't usually put those type on the test. If I do, then I usually make up for it because I don't try to do that unless it's very, 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 very important. And most of the time, if you're given this, most of the time they're going to be above 10. All right. So my confidence interval is going to be between 0.61 and what? 0.65. Put that in terms that you can understand. 61% to 60 what? 5%. Which is pretty much kind of low, but it's, like I said, these problems, you want it higher than that, but anyway. Question. Oops, sorry. Let me go back. Okay. The lower bound is 0.61, the upper bound is 0.65. We are 90% confident that the proportion of registered voters who is blah, 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 blah is between 61 and 65%. Now they're going to ask for the margin of error. Or they're going to ask for n, sorry. They need a sample size. Okay, they hadn't done it yet, but that's the, did we not do this yet? Okay. Write that down. That is the sample size. N is equal to P hat Q hat over your z-score. You don't have to write z sub alpha over 2 because in this section, everything is z sub alpha over 2. So your 1.645 is going to go in right there. So you don't really have to put z sub alpha over 2. You can just put z with the assumption that everything is alpha over 2. Z over E. What is E? Margin of what? Error. That's squared. So you can clean that up. You don't have to write 1 minus P hat because that's Q hat. I don't know why they started doing that. Evidently, y'all are not smart enough to realize that 1 minus p hat is q hat. So they're trying to dummy it down for you, I guess. I don't know. And then z, you don't have to write z sub alpha over 2. So you have p hat q hat times z over e squared. That'd be the easiest way to write it. Okay, and I'm not going here right now. I want them to do a, why are they showing it again? Okay, that's if there's no, right, that, okay. First of all, I don't have to tell you this, but if they don't give you P, then you are to assume 50-50. What's 0.5 times 0.5? 0.25. So you can write this two different ways. If you want to memorize two formulas, or you want to just use your brain, okay? However you want to do it. If P is unavailable, if they do not give you P hat, then you're to assume 50-50. That's using your brain. If you want to use a second formula, then you write that formula down right there. I tell students just think of 50-50. If they don't give you P, if they don't give you X over N, if they don't give you X and N so you can figure it, if they don't give you a percentage, if they just say, find the confidence interval, blah, 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 then you say, okay, there's no P, so it's 0.5, which is equal to 0.25. So however you want to memorize that, that's fine. I don't want to insult your intelligence and make you memorize two formulas when you can just use common sense. Okay, here we go. This is the second, third really, because the first example we did P hat, Q hat. The second example, we actually found the upper and lower interval, okay, the upper and lower bounds. This is the third example where we're actually trying to find a sample size. These are 3 test questions that we've gone over today. All right, so a sociologist, blah, 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 blah. What sample size, write that down, what sample size should be obtained if she wishes her estimate be within 3 percentage points? How do you write 3 percentage points? 0.03. Remember, you can't do 3%. You have to do 0.03. So write that down, say 3 percentage points, highlight that, and put equals 0.03. Because some of you are going to mess, I'm sorry, just 3. When you put it in there, it should be 3. Just write down 3. We'll get to that in just a minute. With 90% confidence, okay, 90% confidence means alpha over 2 is equal to what? 0.05. And we're going to get to that in just a minute. And blah, 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 blah is 82.4. Now here's the formula. There we go. E is 0.03. There we go. I thought it would be a decimal. 0.03. Z, we got that a while ago, 1.645. And P hat, and this one is 0.824 because what? What did they give you in the question? I want somebody to interact with me.
The estimate of 82.4%.
They give you a what? What is that called? A percent, which means P hat. Remember, proportion, percent, thank you, probability. All of them start with a P. P hat, your favorite word. P hat. 3 words. So you need to highlight 82.4 and say 0.824 is equal to P hat. Therefore, Q hat is equal to 0.176. Always figure your P hat, your Q hat after your P hat. So you'll have it. And there it is. So N, now, is there such thing as 0.04 people? Now, this is engineering math. You always round up. Tensile strength of an I-beam. You always want to round up. If you don't, then you have what happens up there in Clemson with those people dancing on the floor, which was stupid. There was too many people in there. So anyway, and you get a bunch of people jumping around. Harmonic function, dang old harmonic function. You bring down what? Dang old bridge. People jumping at the same time. Forget it. Anyway, so I'm going to say 437. Yes, ma'am.
Why is the Z-score the same? Or wait, if it's like always going to be like the same confidence level, that doesn't change it.
Yeah, well, so the most of the time they're going to hang around 90%. on the homework problems. I doubt very seriously you're going to see an 85% confidence level, but on homework, they regenerate the numbers so that you possibly could. But on a test question, you're not going to see below 90%. Now, let's draw you a picture of an index card. I'm going to do that right quick. I got to pull up my whiteboard. And we're going to go through and do this for you. Oh, there's my whiteboard. I already got it. Dadgum, I'm on the ball today. Take your dang old index card, draw an index card on you, and I want you to divide it into several columns. And this is what you need to do for the one person that does it. You need to do one column, and we'll call this confidence level. And I want you to measure 90, 91, to 90 what? 99. And then here, I want you to do alpha. Alpha is equal to 0.10. What's alpha at 91? 0.09. What's alpha at 0.99? Okay. And then what's the next column going to be? Alpha over 2, Hubert. Thank you, class. Appreciate the interaction. We spent all semester. Really? One of these days I'm going to get training. You know, we still haven't had training on these boards. Been in 2 years. So confidence level, 90, 91, 92, 99. Alpha, 0.10, 0.09, 0.08, 0.01. Okay, alpha over 2. What's alpha over 2 for a dime? A nickel. What's for 9 cents? 4.5 cents. What's for 8 cents? 4 cents. And What's half of a penny? 0.005. Okay, now what's the last column going to be? Your what? Your z-score, sorry. So that's one, and it's absolute value. So put absolute value marks. 0.05 we said was 1.645. All right, somebody do inverse norm of 0.045 for me. Do those 4 numbers on the board that I got. 0.45, 0.4, and 0.005. What's 0.045?
1.69.
Even?
5.
What?
1.695.
Okay, next one. What's 0.04?
0.04.
1.7506.
750, 751, or whatever. And then somebody do 0.005. .0050. Inverse norm. I'll leave, it doesn't take that long. What?
2.575.
So you'll need to make an index card that's got all those on it. And therefore, that will save you time from having to what? Calculate it. For the 2 people that's going to do it. And that's how you figure in. So you're talking at least, if I give you, on this last test, if I give you 10 math questions, because there's 10 or 15 bonus questions. If I give you 10 math questions, there's 2 right there on the end. I'm going to ask you at least 2 about sample size. Okay? So make sure you can do that. You're going to need the index card for this whole unit. not just for the sample size. You're going to need it for the whole unit. So I would highly suggest that you make a card, unless you just want to calculate it each time, because unless you do 5 or 10 or 15 problems, you're not going to memorize them. So the best thing to do is just write them on an index card. Oh, I don't want to go into t-distribution. Hold on a minute. I think that was just X bar. We know how to do X bar. I think this is T. Go ahead and write down T. I don't know if I'm going to test you on it, but I want you to have it in your notes in case you take a 301 in the future. You could keep this notebook. Okay? Why? Well, one, if you take my 103 class, two unit test in 103 is the first 2 units in here, so you need to keep your notebook so you don't have to rewrite the notes. Okay? So that's one thing. Some of you may take a class at Clemson called Math Science 301. Math Science 301 is basically this class with a little bit more. Okay? Some of you may go into package engineering. Some of you may go into that form. The first 2 or 3 classes comes from this class. All right? So that notebook, do not throw this notebook away, honestly, unless you're just going to quit school next semester. Okay, if you're going to quit school next semester, then at least put it in the attic or somewhere where when you decide that you don't want to make minimum wage the rest of your life and you come back to school, you'll have that notebook, okay, because you will. Okay, so write that down. It's kind of like the same formula we had. It's not very much different from the formulas that you've had before. We're going to cover a little bit of this, but I want to stay on the null hypothesis as well as the alternative, so that means we're going to stay on the proportion, okay? But we'll go back to this. And they give you the z-score, which is the same. There's the same formula that we used before. You've got that in your notes, okay? And I'm not going to draw a histogram, so we're not going to go with that. You see, that's the relationship I was telling you. Is it the same formula? Yes or no? What's the difference? Somebody tell me what the difference is. And no, don't tell me one's got S and one's got sigma. That's not what I want. What's the One's a population, the other one's a sample. The sample is the S, the population is. So really the mathematics is not what? Different. So you need to make that distinction so that you know that it's the same, not really different. Okay, so here they say obtain a simple random sample, blah, blah, blah. N is equal to 5, blah, 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 determine the sample mean. I'm checking because some of y'all are starting to fidget and stuff, and that's why I'm making sure. Okay, I need to finish up here in a second, so I'm not going to take the roll. I'm going to bump the roll. I think that's stupid. Anyway, if y'all get an email, I hadn't turned in roll in the last 2 weeks, so anyway. We're not gonna line up and go to the bathroom and go to the water fountain, and I'm not gonna I'm not gonna change diapers or anything like that. So it's stupid. Okay, I'm not gonna worry about that too much. Not gonna worry about that. Not gonna worry about that. All right, write this down. Find the t-value such that the area under the t-distribution to the right of the t-value is 0.2, assuming 10 degrees of freedom. Now, there is a t-table in where the table is, and you have to use that t-table. Okay? We'll discuss the calculator Wednesday. Okay? We'll discuss that. I'm not going to get the calculator out with the t-value right now. But find the t-value such that the area under the t-distribution to the right of the t-value is 0.2, assuming 10 degrees of freedom. So the area is 0.2000. Degrees of freedom is 10. What do you have to do to degrees of freedom? You take 1 off of it, so the degrees of freedom is going to be 9 on your t-table. That is, find t sub 20 with 10 degrees of freedom. Okay, they're just restating the question there. All right, so, and they're going to tell you, they're showing you what to do. And if you look it up in the t table, you're going to see it's going to be 0.879. All right, so the t value The t-value is the sample z-score versus the what? The z-value, which is the what? Population, or vice versa. The z-score is the same as the t-score. Bless you. Okay? And 1 minus da. Go ahead and write this down. Again, you're not seeing a very big difference. What's the difference? The first one has a z. This one has a what? T. And Wednesday, we're going to talk about the calculator finding the t, and therefore you can use the table to find a t. Why? Why would you use t if the question what? Is in the t, if they give you t sub versus z sub. That's the only difference. And you will be given the t question when we're talking about null hypothesis and alternative. So there's really not much difference in the formulas. And they're going to give you that, and I'm not going through that right now. I'm covering the hot spots, and these are just more. This is more lower bound, upper bound. I think we'll stop right there. Okay? Because I don't want y'all to get too much on here. Let me turn off y'all can go ahead, unless y'all need to line up and go to the bathroom. See y'all.